Good morning, grade 7s. Welcome to your daily lesson of mathematics brought to you by WorksheetCloud.com. I hope you guys are all really well this morning and looking forward to today's lesson. Just a reminder of the email address on your screen, grade7@WorksheetCloud.com. Please feel free to use it to send me any feedback, suggestions, questions, queries, requests for topics that you'd like me to cover again, or maybe in full, or maybe give it a bit of a further explanation and work through some examples on the Google Jamboard. I'll be more than happy to do so with you. Just send me an email to the email address on your screen. So let's have a look at what we're getting up to today. You got a warm-up just to get the brain in the mood. Then you got mental arithmetic questions covering previously taught principles. And then we're going to have our main theme of the day, which is dividing terms and substitution in algebra. Some really important concepts that you're going to need to know for grade 8 and beyond. And then we've got our brain bender and challenger to finish off on. So let's listen close. Let's get involved with the lesson. Make sure you got pen and paper ready to do some calculations. I always say write things down so you can see your thoughts instead of sort of holding them in your memory. It often makes life a lot easier for you. Here's your warm-up. It's a fraction theme. Okay. You guys should know that you need to find the value of each symbol and then the question mark at the end. Take your time. There's no rush. Check your work where you can. If you need to start over again, that's not a problem. Don't give up on it. Let's see how you guys get on. On the third line, and I know that 1 over 10 plus 9 over 10 is going to give me 10 over 10, which is a whole number, so I can write that whole number as 1. And now I'm just going to fill in what I know. So I know that the monitor is equal to 9, so that's 18 over 9. So remember, that's equal to 2, so let's just write that in brackets. And I know that the capsule is equal to 10. Okay, so this equation at the top, 18 over 9, which is 2. And now I need to figure out how I can make heart over 3 plus virus over virus. How do I make that equal to 8? Because 2 plus 8 is 10. And as we said, 18 over 9 is equal to 2. So if I work that out, I'm going to have to get 21 over 3. And that is equal to, and I'm just going to squeeze it in here, that's equal to 7. Okay. So now I've got 2 plus 7 is 9. And over here, you can see that the heart and the virus are equal. So that means 21 is equal to 21. And we know that any number over itself is equal to 1. So now I've got 2 plus 7, which is 9, plus 1, and that gives me 10. Now I just need to go to the bottom of the screen and just fill in what I need to know. I've got 9 plus 21 plus 10 minus 21. Okay, and I can see straight away that plus 21 and minus 21 will cancel each other out. So I've got 9 plus 10, so my answer is 19. Okay, so the trick there, I think, was the top line, or the difficult part was the top line where you needed to figure out fractions that could add together to give you the answer of 10. Go back, rewind, have a look at my explanation and the way I went about finding those fractions and those answers. And as always, send me an email if you'd like me to explain it further. Let's go have a look at our main theme. Let's go have a look at our mental arithmetic questions for today, which comes before our main theme. Mental arithmetic questions are on your screen: addition, subtraction, long multiplication, some short division, mixed numbers, and adding fractions, division and multiplication percentage. So you got the whole bang shoot there. Guys, take your time. There's no rush. Write everything down. Remember to check your calculations. Very important to check. We've been through checking strategies numerous occasions, but take your time and let's see how you guys get on. 1,937 plus 572,381. As you can see, I've put them on the screen already. We just add normally. Okay, and you know that the decimals line up, and we are left with 1,274,318. The checking strategy is to subtract one of the numbers in your question, and that needs to give you an answer of whatever number is left. So I'm going to subtract 572,381, and hopefully that leaves us with the 701,937 at the top. So 8 minus 1 is 7. They line up. Great. I need to borrow. 11 minus 8 is 3. Okay, those two are the same. Again, I need to borrow. 12 minus 3 is 9, and they are the same. My decimal lines up. 3 minus 2 is 1. They are the same, so all good. 7 minus 7 is 0. They are the same. And 12 minus 5 is 7. And those guys are the same. So happy days, my calculations work out. I can move on in a confident manner. Okay. Your next question is a subtraction question. Okay. And that's 461,98. Subtract 345,17. So 461,98. Take away 345,17. Okay, and we subtract normally. Decimals line up. We borrow where we have to, and that gives us 116,81. And remember, the checking strategy here is to do the opposite of subtraction, which is addition. So we add 116,81 to 345,17, and then that should give us 461,98. So 1 and 7 is 8, good. 8 plus 1 is 9, good. 6 plus 5 is 11. 1 and 4 is 5, and 1 and 3 is 4. So everything works out. My calculation is correct. Again, I can move on in a confident manner knowing that that calculation is correct. Long multiplication, 109 multiplied by 43. So I'm going to do this column method first. 3 times 9 is 27. 3 times 0 is 0, plus the 2 is 2. And 3 times 1 is 3. So 109 times 3 is 327. Always remember that placeholder, because now we're multiplying by a multiple of 10. And then 4 times 9 is 36. 4 times 0 is 0, plus the 3 is 3. And 4 times 1 is 4. Then I need to add it, and I get 4,687. But let's have a look at another method to see if that is actually the correct answer, and I'll leave that answer at the bottom. So I'm going to say let's split up 109 times 43 into 109, and then 43 into 40 and 3, and let's just work this out quickly. 100 times 40, we know 100 times 4 is 400, so 100 times 40 is 4,000. 100 times 3 is 300. 9 times 40, or 9 times 4 is 36, so 360, and then 27. And if we add up 4,360 and 327, so if we add these two numbers up, let's do it quick. 7, yep. 8, yes. 6, yes. And 4, absolutely. So, I'm really happy that my calculations using both methods has worked out. Remember, you choose whatever method you are comfortable with, and whatever method makes the most sense to you. But as always, guys, please check your work as much and as thoroughly as possible. All right, we've got a short division sum next, and it's short division because you're only dividing by a single digit, okay? And I'm just working through it, and you can see 9,142, but we must check by taking our answer and multiplying it by the divisor. Multiply because that's opposite of divide. 5 times 2 is 10. That's going to be 21. That's going to be 7, and that's going to be 45. And does it match up? Yes, it does. So I know my original calculation must be correct. Okay, let's look at number 5, which is the addition of a mixed number in 1 and 3 over 10 plus 2 over 3. Okay, so I'm going to change it to an improper fraction. That's 13 over 10 plus 2 over 3. We need to look for the lowest common denominator of 10 and 3, and that is 30. So 10 goes into 33 times, so 3 times 13 is 39. And 3 goes into 30 10 times, so 10 times 2 is 20. So if I add those two together, I'm going to get an answer of 59 over 30. And if you want to change it into a mixed number, that's going to be 1 and 29 over 30. So 1 and 29 over 30. But it should be good for you to leave it as an improper fraction unless you are asked to convert it into a mixed number or mixed fraction. 9 times 100 in question 6. We know that when we multiply, the number gets bigger. When we multiply by 10, it gets 1 place bigger. When we multiply by 100, it gets 2 places bigger. So that answer is 289. Okay. Question 7. When we divide fractions, I've always said to you, make sure you have 2 fractions so you can write a whole number as over 1. So now I've got 2 fractions. Remember, the division sign changes to multiply, and that second fraction gets inverted to its reciprocal. So now I've got 4 over 7 times 1 over 5. I can't simplify diagonally. So 4 times 1 is 4, and 7 times 5 is 35. And that's your answer. Then we got 3.5 times 5. Okay, and I would again say convert to an improper fraction. So you know that 3.5 is equal to 7 over 2. Okay, and then multiply that by 5 over 1. Okay, and then we'll have 7 times 5 is 35, and 2 times 1 is 2. And yes, if you have to convert that into a mixed number, that will give you an answer of 17 and a half. Okay, so 17 times 2 is 34. Half times 2 is 1. 34 plus 1 is 35. Okay, and then your last question is the percentage. All right, so 30% of 160. Okay, so 10% will equal 16. So 30% will equal 16 times 3, which is 48. Okay, if you want to do continue, or if you want to do use fractions, remember 30% is 30 over 100, which is 3 over 10 simplified. So always simplify your fractions before calculating. It makes the calculation a little bit easier. Okay, we can simplify diagonally because 10 goes into 10 once and goes into 160 16 times. And now you can see our numerators. We have 3 times 16, which is 48. Those answers are the same, so I'm happy I can move on. Okay, guys, so those are principles that we've been going over for a while. Make sure you understand them. Make sure you understand the checking strategies. Make sure you're writing all your calculations down, because very often, more often than not, if you show your calculations and you make a careless error, you'll often get, say if the question's out of 4, you might get 2 out of 4. Okay, so don't just write the answer down, because then if you get it wrong, you get absolutely nothing. You can still get method marking. So I encourage you to always write down your calculations and please check your answers. Right, let's get into the main theme of for today, which is algebra and dividing and substitution. So dividing terms. So in algebra, we do not usually use the division sign. You can, but it's not often used. Instead, we write the number or term we are dividing by underneath, like a fraction, because remember, a fraction means the numerator divided by a denominator. So for example, a plus b divided by c, we can write as a plus b over c. Okay, so that's just one of the do's or don'ts that you need to understand. So yeah, instead of division sign, we write it as a fraction. So if we divide terms, we, as the same with fractions, we can simplify expressions by cancelling. So what do we mean by that? If I have n cubed divided by n squared, we can write it as n cubed over n squared as indicated in the fraction. And now we can have a look at writing it out in full. N cubed is n times n times n, and n squared n times n. And now we can simply just cancel out. Okay, so that n cancels with that n, and again the second n cancels with the second n. So now we're left with 1. In the numerator, we're left with 1 times n, which is equal to n. And in the denominator, we're left with 1 times 1, which is 1. So essentially, we've got n over 1, and that is equal to n, because anything over 1 is equal to that anything. Okay? If I gave it to you in this format, you could write it as 6p squared divided by 3p. If you wrote it out in full, you would have 6 times p over 3 times p. And now you can see that the 6 and the 3, they cancel out. 6 divided by 3 is 2. And 3 divided by 3 is 1. And then those two p's cancel out as indicated. So in your numerator, you have 2 times p, which is 2p. And in your denominator, you have 1 times 1, which is 1. So 2p over 1 is equal to 2p. So that's how we divide terms in algebra. I encourage you to go back and have another listen and to make sure that you understand the concepts involved. Okay, let's have a look at this. If I say to you 4 plus 3 times something, how would you work that out? Well, you know, you couldn't. You needed the 8. So first of all, you would say 3 times 8 is 24, and then 4 plus the 24 is equal to 28. And just bear with me here. We'll get to the learning point soon enough. Again, if I move that to 4 plus 3 times 5, first you're going to say 3 times 5 is 15 plus the 4 is 19. Okay, if I change that 5 to 43, you would still do 3 times 43, which is 129, plus the 4 is 133. Okay, I could change it again, and this time it's going to be 1.8 plus 4, which is 5.8. I could change it again. That's going to be negative 21 and 4, which is negative 17. Okay, here again, I could change that square for a number. So every time I'm changing the square with a different number, and I'm hoping that you guys are starting to figure out what I'm doing. So I first do 7 times 6, which is 42, and that divided by 2 is 21. I could change it to 7 times 9 is 63 divided by 2 is 31.5. And I could continue to change the value of that square to pretty much whatever value I want it to be. Okay? And I'm hopefully going to lead you to something which we call substitution. Okay? Now remember, in sport, when I take one player off and I put another player on, it's called substitution. And we can do the same thing in algebra. Okay, we can take a square for this example and we can change the value all the time. So we are substituting the square with a number and we are working it out each time. Okay, and that can work with pretty much all operations that I'm going through. So you can see now we are squaring numbers. Before we multiplied, we showed you dividing numbers, and this is the concept of substitution. Okay, notice that order of operations is important. So 0.2 squared is equal to 0.04, and then you add the 6. Negative 4 squared is negative 4 times negative 4, which is 16. Remember, negative times a negative is a positive. And then we add the 6 to get 22. And it's also possible in brackets. So if I put that 7 in brackets, you know you do the bracket first. 7 plus 8 is 15. And then multiplied by the 2 is 30. I can do it again. Okay, so that's 18 plus 8 is 26 times 2 is 52. And I can continue substituting values and working out the new answer every time with my new substituted value. Okay, so I encourage you to go through these again if I'm going through them too quickly for you, and see if you can actually work them out and see if you can get the correct answers. Okay, so what does substitution mean? As I've already alluded to, when we replace letters with an expression or equation with numbers, we call it substitution. So very similar to the sporting example I gave you. So how can 4 plus 3 times something be written as an algebraic expression? So we could use n for the variable. So the square here is the variable, because remember, variables vary, okay, and they change in value. So we can write it as 4 plus 3n, because remember, we leave out the multiplication sign. So 3n means 3 times n, okay? And then you can tell me, or I can tell you, or your examiner or your teacher can say to you, what is the value of 4 plus 3n when n is equal to 5? So all those examples that I went through for you before we got onto the substitution slide, where we were substituting numbers in for that square, and that square was the variable. So now if I say, okay, n is equal to 5, then it must be 4 plus 3 times 5, and we can work that out as 3 times 5 is 15, plus the 4 is 19. Okay, so that's how substitution works. If I said n was 11, same again, we take the n out, we put the 11 in, so that's the substitution. So we know that 3n means 3 times n, so if 11 is put into n, then it must be 3 times 11, which is 33, plus the 4 is 37. Okay, so that is the concept of substitution. Okay, we replace a letter with a number, and we can work it out. So here's some more examples. That can be written as 7n over 2, as I've explained to you on a few occasions. And now we can evaluate 7n over 2 by giving n a value. Okay, regardless of what the value for n is, we can use any number for n. The process and the principles remain the same. So here we will have 7 times 4 divided by 2. So 28 divided by 2 is 14. Okay. If I said n was equal to 1.1, again, I take the n out, I put the 1.1 in. So that becomes 7.7 divided by 2, which is 3,85. Okay, so make sure you understand the concept of substitution, and go over the slides and go over the examples to make sure that you understand the process involved. We went through some examples with exponents, and there it can be written as, or here it can be written as n squared plus 6. Now I can give n a value, given the n a value of 4. So that means 4 squared plus 6, which 4 squared is 16 plus 6, and that is equal to 22. If I gave n the value of 0,6, same thing again. 0,6 is the squared number. That becomes 0,36 plus 6, so 6,36. Okay, so again, substitution can occur in multiple ways, but the process and the principle remain the same. Very important for you to understand that, guys. And then the final one we're going to look at is brackets. So if I put n in place of that square, it becomes 2 multiplied by, in brackets, n plus 8. We can now use a number instead of n. Remember, we do the brackets first. So that becomes 2 multiplied by 6 plus 8 in brackets. 6 plus 8 is 14, so it becomes 2 times 14, which equals 28. And another example, if I said n was equal to 13, we take the n out. You've had a bad game, you've missed too many goals or tackles or whatever it may be. Let's put 13 in there, you might do a better job. That's pure substitution. 13 plus 8 is 21, so we do the brackets first. 2 times 21 is 42, so 2n plus 8 is equal to 42 when n is equal to 13. Okay, and guys, that's substitution. Okay, so here are 5 examples for you to do. I'm going to press pause. I'm going to let you work through them and then press play to see how you guys get on. For a plus b plus c, a equals 5, b equals 2, c equals -1. So there we can just add or subtract from left to right. We know 5 plus 2 is 7, and then a positive and negative sign together is a negative sign. So that's going to be an answer of 6. Okay. Second one, 3a plus 2c. I substitute 5 for a and -1 for c. So now it becomes 3 times 5 is 15, plus 2 times -1 is -2, because it's positive times negative, so that becomes negative. So 15 minus 2 is 13. Third example, if I substitute the numbers in for those letters, we know that a open brackets b plus c means a times b plus c. And if I substitute those numbers in, first do the brackets, so 2, and that becomes -1 because it's a positive and negative sign together. So the bracket will be 1, and that becomes 5 times 1, which is equal to 5. Question 4, a times b times c. Remember, we can leave out the multiplication signs when we're dealing with the letters, but that becomes 5 times 2 times -1. 5 times 2 is positive 10, then positive 10 times -1, it's a positive times a negative, so that becomes -10. And the last one, b squared minus c over a, if I substitute in, it looks like that, 2 squared minus -1, okay? So don't be confused with the minus part. We keep the original minus sign where it says minus c, and because c is worth -1, we need to include the negative sign with it. So a double negative sign becomes positive. So it'll be 2 squared is 4. Minus and minus together is positive. So it becomes 4 plus 1. So that's 5. That's how I get the 5 at the numerator. My denominator is already 5. And 5 divided by 5 is equal to 1. Guys, please go back. Have another listen. See if you understand. If not, send me an email and I'll get back to you. Have a look at the online activity with Memo that you can practice these concepts. And just keep looking at the recording, keep listening to the explanations, and keep practicing, and you'll find that you pick it up rather quickly if you continue to practice on a regular occasion. If you only watch this video and then leave it, then it's highly likely that you're going to forget this work moving forward. So really important concepts to understand, because they'll become quite regular and you'll see them quite frequently when you get into your high school education. So make sure you understand these algebraic concepts moving forward. Guys, that brings us to the game of 24, which we'll finish off with for today. Use each card. So on the first card, you got 4, 4, 8, and 7. Use a combination of the operational signs and try to come up with an answer of 24. Remember, the order of operations is important. See if you can get the answer of 24 on a minimum of 3 occasions. If you can get it on more than 3 occasions, then you're doing well with your mental arithmetic, and you can take confidence from that. And I encourage you to challenge someone at home to see if they can beat you, or indeed you can beat them. And then just a final reminder about the email address at the bottom of your screen, grade7@worksheetcloud.com. Please feel free to send me any feedback, suggestions, questions, or queries. Guys, thanks very much for joining me. I hope you guys learned something today. A reminder of all the previous lessons that are on WorksheetCloud.com with activities and memos. It's a great resource for you guys to further consolidate and understand the work that you need to know in your grade, and especially moving forward into grade 8 and above. Have a super day. All the best. Take care. Cheers.